Hi there, my name is Lilly. I'm the founder and executive director of Howard Ecoworks. Happy to present to you today about mobilizing a biochar movement in Maryland. My organization, Howard Ecoworks, was founded in 2016. Our mission is to empower communities and diverse workforces to respect and restore our natural systems for future generations. For us, this is a dual mission for both workforce development programming and environmental improvements. Our services largely revolve around designing, building, and maintaining various environmental projects and best management practices with our Green Jobs programs. We are advocates for biochar because of the many environmental benefits that it provides. Biochar can help to improve the soil by adding carbon and organic matter to the soil, thereby improving the health of the soil and the plants that are growing there. It has a tremendous potential for sequestering carbon in the ground and helping us to mitigate climate change. We are very concerned here in the Chesapeake Bay with water quality, and biochar offers a lot of potential with improving water quality by removing nutrients and bacteria and heavy metals from stormwater. Biochar can help to retain groundwater in the soil and in the ground. And lastly, it offers a lot of potential opportunity for conversion of wood waste or other organic waste that might otherwise just end up in the landfill. And there's an opportunity to convert that waste into something that is very beneficial for our environment. We feel that biochar has a lot of potential to be scalable. In the Chesapeake Bay watershed, we have 3.8 million acres of lawn and turf grass that provides very little ecosystem service benefit. This is all area that could potentially be utilized to improve water quality and sequester carbon in the ground through biochar soil amendment. There's some companies like Davy Tree that are utilizing biochar as a lawn amendment or a fertilizer alternative. And this, we did some back of the envelope calculations with ridge to reefs and found on a half an acre of lawn, we could sequester up to 8 tons of carbon dioxide in a year, 14 tons in 30 years. And the work that Davy Tree has done, they found that 1.7% biochar applied to lawn more than doubled the turf grass growth in 90 days. So we think this is a great opportunity to utilize biochar. Another scalable opportunity that we've looked more in depth at is in the Tiber Watershed, a small watershed of 3.7 square miles that drains to historic Ellicott City, Maryland. Ellicott City has a history of floods, including 3 in the past decade, 1 in 2011, and then 2 devastating floods in 2016 and 2018. The current mitigation plans for Ellicott City are extremely expensive and involve a lot of heavy infrastructure projects that will take a long time to implement. And so our focus is how can we utilize these lawn areas that comprise 800 acres of the watershed to start to make progress on mitigating stormwater. Not that we think that this is going to mitigate all of the floods, but it is something that we can do now while these longer term infrastructure projects are put into place. So there's an opportunity that we would like to take advantage of here in this watershed. We received a grant 2 years ago from the National Fish and Wildlife Foundation to work in the watershed to engage private landowners and projects to convert their lawn areas to more permeable landscapes like native bayscapes and rain gardens and tree plantings. We also utilized that grant to engage the University of Delaware in a research project to determine if the soils in this watershed would be appropriate for biochar amendment. This 2 graphics show you the watershed outlined in purple. and the opportunity that we feel is available in this 3.7 square mile watershed. University of Delaware has found that silt loams and loams are the best for soil types for biochar amendment, and those in the watershed are around 600 acres comprised. We also have the 800 acres of turf grass that I mentioned, and we also have this utility right-of-way that bisects the watershed, if you can see my cursor here. And, the utility right-of-way, folks don't want to see large-scale mitigation projects in their right-of-way, but there could be an opportunity with biochar amendment in the right-of-way to intercept stormwater from the upper areas to the lower part of the watershed. So those are all opportunities that we see in this watershed. So we installed with the University of Delaware grad students test plots at 2 different sites. And we did 2 5x5 plots, one plot amended with biochar and the other was the control plot. And these were installed in March of 2019. The University of Delaware used saturated hydraulic conductivity as their measurement for how well the biochar would infiltrate into the soil as a surrogate measure. And they found that the biochar amendment increased the saturated hydraulic conductivity by a factor of 2 to 10. So it was pretty significant, especially in the slack site. And this is a visual representation for what that looked like spatially across the 5x5 test plot. The control on the right showing no increase in saturated hydraulic conductivity, and the graphic on the left showing how much it increased across the test plot. So the University of Delaware used an infiltration calculator from the results that they obtained with the saturated hydraulic conductivity to show that the biochar amendment increased stormwater infiltration by almost 100%, more than 95% in the slack site, so extremely significant. Another point that I would like to add with regards to biochar is the historical precedent that we have with fire as a management tool and maintaining our landscapes and our habitat. We see a lot of these destructive fires out west, and they are largely a result of fire suppression. We do have the same thing here on the East Coast, though our natural fire regime is historically much less frequent and severe than what you would see out west, but it has been used, or it has been an ecological factor in shaping our forests and our habitats. And even the Native Americans would utilize fire as a tool to manage wildlife and mass trees and food sources. So there is a precedent for fire and, the subsequent charcoal and amendment to the soil with nutrients from fire in our ecosystems here out in the East. I did my master's thesis project on the eastern shore of Maryland on these what are called ancient xeric sand dunes, and these are landforms that were formed millennia ago from geological processes and wind that form these inland forest systems that are very unique and harbor many rare, threatened, and endangered species and unique plant communities. And some of the research that I did was looking at cores from the trees and looking into the disturbance history of those forest systems to see where we were seeing releases in the growth of the trees as a result of disturbance. And the theory was that some of that would have been from fire. Our ecosystems here on the East Coast, especially in our urban and suburban areas like where I am, are dominated by invasive plant species. Our forests are extremely unhealthy. Here you see some pictures of the top left, a plant called Japanese barberry that is infesting our woods. In the top right is Japanese stilt grass that is covering the forest floor. Deer are also creating a huge impact that is being exacerbated by these invasive plants. But generally, we have these forests without any kind of significant understory or native ground cover or shrub layer. In the bottom left is a picture of English ivy, which is an invasive vine that climbs up the trees and shortens their lifespan and makes them more susceptible to wind damage and toppling. And then on the right is a picture of a tree, an ash tree that's been infected with emerald ash borer. And the sloughing of the bark comes from the pileated woodpecker that's coming to feast on the little larvae that are in there. So the point being that our forest systems are, especially out east, are very unhealthy, and some of this has to do with the suppression of fire in our landscapes that would otherwise control these invasive plants and allow for healthier ecosystems to thrive in our area. And I think that this is, for me, it's another reason to advocate for biochar. While we again, as a society, may not be amenable or open to the idea of prescribed burning to control some of these invasive plants that are infesting our forests, we can utilize biochar on controlled biochar burns as a way to manage some of these invasive plants and degraded forest health on a smaller scale. Here's a picture of a kiln designed by Kelpie Wilson and built by Bill Knapp here in Ellicott City. And we been using it to turn some of our wood waste into biochar. And so I would just like to add that I think that we can utilize biochar production as a way to mimic what we have lost in terms of these large scale ecological processes of fire management in our landscapes that have been used to create healthier systems. And so we can scale this to many different ways. This is a homeowner scale here, my scale, but we can scale this to a municipality, to a region, and of course across the nation. And because we have so many environmental benefits from biochar, and because it is timely with the climate crisis, this is why we are interested in advocating for biochar and a bigger movement in our region. Thank you for your time this evening or this afternoon, and I'd be happy to entertain any questions in the panel session. Thank you.